Signal flow graph. Signal flow graph is a graphical representation of algebraic equations. The block diagram reduction process takes more time for complicated system. So to overcome this drawback, use signal flow graphs is done where the calculation of transfer function is just by using a Mason's gain formula without doing any reduction process. The basic elements of signal flow graphs are node and branches. Node is a point which represents either a variable or a signal. There are three types of node. First one is input node, second one is output node, and the third one is mixed node. Input node is a node which has only outgoing branches. Output node is a node which has only incoming branches. Mixed node is a node which has both incoming and outgoing branches. Forward path. It is a path from an input node to an output node that does not cross any node more than once. Individual loop. It is a closed path starting from one node and after passing through the graph arrives at the same node without crossing any node more than once. Non-touching loops. If a loop does not have a common node, then they are said to be non-touching loops. Example, let us consider the following signal flow graph to identify these nodes. The nodes represented in the signal flow graphs are y1, y2, y3 and y4. y1 and y4 are the input nodes and output nodes respectively. y2 and y3 are mixer nodes. A branch is a line segment which joins two nodes. It has both gain and direction. For example, there are four branches in the above signal flow graph. These branches have gain of a, b, c and minus d. The signal flow graph by considering the following algebraic equation: y2 equal to a1 to y1 plus a4 to y4, y3 equal to a23 y2 plus a53 y5, y4 equal to a34 y3, y5 equal to a45 y4 plus a35 y3, y6 equal to a56 y5. There will be 6 nodes y1, y2, y3, y4, y5 and y6 and 8 branches in this signal flow graph. The gain of the branches are a12, a23, a34, a45, a56, a42, a53 and a35. To get the overall signal flow graph, draw the signal flow graph in each equation, then combine all these signals flow graph and the steps are given below. The signal flow graph for y2 equal to a13 y1 plus a42 y4 is shown in the following figure. And step 2 shows the y3's signal flow graph. Step 3 shows the y4 equal to a34 y3's signal flow graph. y5's signal flow graph is shown in the step 4. In step 5, y6 is given. Signal flow graph of overall system is shown in the step 6. The conversion of block diagram into signal flow graph is it represents all the signals, variables, summing points and takeoff points of block diagram as node in the signal flow graph. It represents the block of block diagram as branches in signal flow graph. It represents the transfer function inside the blocks of block diagram as gain of the branches in signal flow graph. It connects the nodes as per the block diagram. The assessment question: let us convert the following block diagram into its equivalent signal flow graph. Here R of s is the input and y of s is the output. y1, y2, y3, y4, y5, y6 up to y9 are the nodes. Gains G1, H1 are given here. We need to convert the following block diagram into its equivalent signal flow graph. Try yourself. And also the answer for the above block diagram is given here. With the help of Mason's Green formula, you can calculate the transfer function of this signal flow graph. To simplify the signal flow graph for calculating the transfer function, the Mason gain formula is given by, it represents all the signal variables, summing points and takeoff points of block diagram as nodes in signal flow graph, represents the block of block diagram as branches in the signal flow graph. It represents the transfer function inside the block of block diagram as gain of the branches in signal flow graph, and connects the nodes as per the block diagram. The Mason gain formula is given by C of s divided by R of s equal to summation I equal to 1 to n pi del I divided by del, where C of s is the output node, R of s is the input node, T is the transfer function or gain between R of s and C of s, Pi is the ith forward path gain, and del equal to 1 minus sum of all individual loop gains plus sum of gain products of all possible 2 non-touching loops minus sum of gain products of all possible 3 non-touching loops, and so on. Del I is obtained from del by removing the loops which are touching the ith forward path. Thank you.